first we take a clean Erlenmeyer flask off the shelf and put it on the work table. Then we're going to go over to the materials shelf and add 15 milliliters of 6 molar hydrochloric acid to the flask. Now we're going to close off the flask to make it a closed system, and we're going to add a thermometer and a pressure gauge. Now at this point we're going to add 0.25 grams of zinc to the flask. And we're going to record the temperature and pressure changes.
This reaction is a single displacement reaction. Since we know the gas hydrogen is formed, we are left with a product of zinc chloride, which remains in aqueous solution. So we combine 2 moles of hydrochloric acid with 1 mole of solid zinc to yield 1 mole of H2 gas and 1 mole of dissolved zinc chloride. Of the products, the hydrochloric acid separates because it is a strong acid. The zinc ion can form an ionic bond with the chlorine ions, leaving hydrogen from HCl to form H2, which results in the bubbles that we saw in the first couple of seconds in the reaction.
Back at the workbench, we have to wait for the temperature to drop back to room temperature, which symbolizes that the reaction has finished occurring. Now, we see in these instructions that we can repeat the experiment with 25 grams of zinc, so while we are waiting on the other reaction, let's go ahead and do that. We're going to set up this experiment the same way as the initial experiment, except with 25 grams of zinc, and close it off, and it explodes. This tells us that the limiting reagent was the zinc ion, since once we added more zinc, the reaction produced more hydrogen. In order to measure exactly how much more hydrogen is produced, we're going to run the experiment again. We're going to put 15 milliliters of the hydrochloric solution into a closed system, but this time we're going to add a gas syringe to the top in order to measure the volume of hydrogen produced. Then we're going to add 25 grams of zinc. At the moment of the reaction, the volume of gas produced is 1,417.4 milliliters. However, the volume reading goes down as gas escapes the now open system. Also, we can see that there is still solid zinc at the bottom of the flask, which tells us that this time HCl was the limiting reagent. And now that the initial reaction is coming back to room temperature, we can dispose of this system.
Once the reaction is finished occurring, we're going to clear the workbench by disposing of the pressure gauge and thermometer. However, before we dispose of the Erlenmeyer flask, we're going to measure the volume of H2 gas produced by attaching a gas syringe in the closed system. We see the volume measured by the syringe at 92.4 milliliters, which we are going to record in our lab notebook. Here we can see both reactions of HCl and zinc side by side and the amount of H2 produced. Finally, we're going to clean up the workbench by safely disposing of all of the materials.